The National Electrical Code generally prohibits running electrical conductors under dikes. However, there are exceptions for certain types of cables and conduit systems. This includes direct buried cables approved for underground use, rigid non-metallic conduit, or RNC, and electrical metallic tubing, or IMT. Dikes are typically designed to withstand specific water loads and protect buildings from flooding. Altering a dike can compromise its structural integrity. Therefore, it is important to consult with a qualified engineer to determine firstly if the dike can withstand the weight of the conduit or cable without being damaged, and secondly, if the route of the conduit or cable will not weaken the dike or create a potential breach point. Depending on the circumstances, the following options may be feasible. Firstly, overhead conduit can be used. Run a conduit system overhead, supported by poles or other structures. This avoids the need to alter the dike. Secondly, underground conduit can be considered. Use cables or conduit systems approved for underground burial, such as direct buried cable or RNC. Consult with a qualified engineer to determine if the dike can withstand the installation and the weight of the conduit. Ensure that the conduit is properly installed to minimize the risk of damage. Thirdly, boring under the dike might be an option. In some cases, it may be possible to bore under the dike using specialized equipment. This option requires careful planning and engineering to ensure the structural integrity of the dike. The best option for providing power to the training post will depend on the specific circumstances and requirements in the dike itself. It is advisable to consult with qualified electrical and engineering professionals to ensure a safe and compliant installation. Consider that the National Electrical Code, or NEC, sets the standard for safe electrical installations. Always adhere to the latest edition of the NEC and any local amendments to ensure compliance and safety. Underground installations require careful consideration of soil conditions, burial depth, and protection from physical damage. Direct buried cables must be listed for direct burial and installed at the correct depth, as specified by the NEC. Conduit systems should be properly sealed to prevent moisture and debris from entering, which can cause corrosion and electrical faults. When running conduit overhead, ensure that it is properly supported and grounded. Use appropriate fittings and hardware to prevent water from entering the conduit system. When boring under the dike, be extremely cautious to avoid damaging the dike structure or any existing underground utilities. Use ground-penetrating radar or other methods to locate any buried utilities before starting the boring process. A qualified engineer can assess the structural integrity of the dike and recommend the best approach for providing power to the training post. The engineer can also help to ensure that the installation complies with all applicable codes and regulations. Consider the environmental impact of the installation. Avoid disturbing any sensitive areas or damaging any vegetation. Use environmentally friendly materials and construction practices whenever possible. Before starting any work, obtain all necessary permits and approvals from the local authorities. This will help to ensure that the installation is compliant with all applicable regulations. It is important to understand the different types of cables and conduits that are available for underground installations. Direct buried cables are designed to be buried directly in the ground without any additional protection. Rigid non-metallic conduit, or RNC, is a type of plastic conduit that is resistant to corrosion and physical damage. Electrical metallic tubing, or IMT, is a type of metal conduit that is lightweight and easy to install. When selecting cables and conduits, be sure to choose products that are listed and labeled for their intended use. This will help to ensure that they meet the applicable safety standards. The depth at which underground cables and conduits must be buried is specified in the NEC. The required depth depends on the type of cable or conduit and the location of the installation. Be sure to follow the NEC requirements to ensure that the installation is safe and compliant. When installing underground cables and conduits, be careful to avoid damaging them. Use appropriate tools and techniques to prevent damage to the cable or conduit installation. If the installation is damaged, the cable or conduit must be repaired or replaced. It is also important to protect underground cables and conduits from physical damage after they are installed. This can be done by installing warning tape or markers above the cable or conduit. Consider the potential for future maintenance or repairs when planning the installation. Ensure that the cables and conduits are accessible for future work. Leave enough slack in the cables and conduits to allow for future repairs or modifications. Before energizing the new electrical system, be sure to test it thoroughly. This will help to ensure that the installation is safe and compliant. Use appropriate test equipment to verify the voltage, current, and insulation resistance of the system. If any problems are found, they must be corrected before the system is energized. Grounding is a critical aspect of electrical safety. Ensure that the electrical system is properly grounded to protect people and equipment from electrical shock. The NEC specifies the requirements for grounding electrical systems. Be sure to follow the NEC requirements to ensure that the grounding system is safe and effective. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the requirements for overcurrent protection. Be sure to follow the NEC requirements to ensure that the overcurrent protection system is safe and effective. When working with electricity, always wear appropriate personal protective equipment or PPE. This includes safety glasses, gloves, and insulated tools. Never work on electrical equipment while it is energized. Always de-energize the equipment and verify that it is de-energized before starting any work. If you are not qualified to work on electrical equipment, hire a qualified electrician. Working with electricity can be dangerous, so it is important to take the necessary precautions to protect yourself from electrical shock. Always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Failure to follow the manufacturer's instructions can result in damage to the equipment or injury to people. Keep accurate records of the electrical installation. This includes drawings, specifications, and test results. These records will be helpful for future maintenance and repairs. Consider the long-term reliability of the electrical installation. Use high-quality materials and construction practices to ensure that the installation will last for many years. Perform regular maintenance on the electrical system to ensure that it is operating safely and efficiently. This includes inspecting the cables, conduits, and equipment for damage. Keep the area around the electrical equipment clean and free of debris. This will help to prevent fires and other hazards. The NEC provides detailed requirements for electrical installations in different types of locations. Be sure to consult the NEC to determine the specific requirements for the location of the training post. The NEC also provides requirements for electrical installations in hazardous locations. A hazardous location is an area where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. If the training post is located in a hazardous location, be sure to follow the NEC requirements for hazardous locations. Consider the potential for future expansion of the electrical system. Ensure that the system is designed to accommodate future growth. Leave enough space in the electrical panels and conduits to allow for future wiring. The cost of the electrical installation will depend on a number of factors, including the size of the installation, the type of materials used, and the labor costs. Obtain multiple bids from qualified electrical contractors to ensure that you are getting a fair price. When evaluating bids, be sure to consider the contractor's experience, qualifications, and reputation. Check the contractor's references and license to ensure that they are qualified to perform the work. Do not be afraid to ask questions. A qualified electrical contractor will be happy to answer your questions and explain the different options that are available. It is important to have a clear understanding of the scope of work before signing a contract. The contract should specify the work to be performed, the materials to be used, and the price of the work. Read the contract carefully before signing it. Be sure that you understand all of the terms and conditions. If you have any questions, ask the contractor to explain them to you. The electrical installation should be inspected by a qualified electrical inspector before it is energized. The electrical inspector will verify that the installation complies with all applicable codes and regulations. If the electrical inspector finds any problems, they must be corrected before the system is energized. Keep a copy of the electrical inspection report for your records. This report will be helpful for future maintenance and repairs. If you are planning to install solar panels or other renewable energy systems, be sure to consult with a qualified solar installer. A solar installer can help you to design and install a system that meets your needs and complies with all applicable codes and regulations. Solar panels can be a great way to reduce your energy costs and environmental impact. However, it is important to install them properly to ensure that they are safe and effective. Consider the potential for power outages. Install a backup generator or an interruptible power supply, or opt to provide power during power outages. A backup generator or UPS can help to keep your equipment running and prevent data loss. Power outages can be caused by a variety of factors, including storms, equipment failures, and grid failures. It is important to be prepared for power outages to minimize their impact. If you are planning to install a swimming pool or spa, be sure to follow the NEC requirements for swimming pools and spas. Swimming pools and spas can be dangerous if they are not properly wired. The NEC provides detailed requirements for grounding, bonding, and overcurrent protection for swimming pools and spas. Be sure to follow the NEC requirements to ensure that the swimming pool or spa is safe. If you are planning to install an electric vehicle charging station, be sure to follow the NEC requirements for electric vehicle charging stations. Electric vehicle charging stations can place a high demand on the electrical system. The NEC provides detailed requirements for the wiring, grounding, and overcurrent protection for electric vehicle charging stations. Be sure to follow the NEC requirements to ensure that the electric vehicle charging station is safe. Consider the potential for lightning strikes. Install a lightning protection system to protect the building and electrical equipment from lightning strikes. Lightning strikes can cause significant damage to buildings and electrical equipment. A lightning protection system can help to protect the building and electrical equipment from lightning strikes. Consider the potential for flooding. If the building is located in a flood zone, be sure to protect the electrical equipment from flooding. Elevate the electrical equipment above the flood level or install flood barriers to protect it from flooding. Flooding can cause significant damage to electrical equipment and can create a safety hazard. If you are planning to install a fire alarm system, be sure to follow the NEC requirements for fire alarm systems. Fire alarm systems are designed to detect fires and alert people to evacuate the building. The NEC provides detailed requirements for the wiring, grounding, and overcurrent protection for fire alarm systems. Be sure to follow the NEC requirements to ensure that the fire alarm system is safe and effective. If you are planning to install a security system, be sure to follow the NEC requirements for security systems. Security systems are designed to protect the building from intruders. The NEC provides detailed requirements for the wiring, grounding, and overcurrent protection for security systems. Be sure to follow the NEC requirements to ensure that the security system is safe and effective. Consider the potential for vandalism. Protect the electrical equipment from vandalism. Install fences, gates, and security cameras to deter vandals. Vandalism can cause significant damage to electrical equipment and can create a safety hazard. If you are planning to install an irrigation system, be sure to follow the NEC requirements for irrigation systems. Irrigation systems are used to water lawns and gardens. The NEC provides detailed requirements for the wiring, grounding, and overcurrent protection for irrigation systems. Be sure to follow the NEC requirements to ensure that the irrigation system is safe and effective. Always consult with a qualified electrician before making any changes to your electrical system. A qualified electrician can help you to design and install a safer and compliant electrical system. Working with electricity can be dangerous, so it is important to take the necessary precautions to protect yourself from electrical shock. The information provided here is for informational purposes only and should not be considered as professional electrical advice. Always consult with a qualified electrician or engineer for specific guidance on your project. Remember to prioritize safety and compliance with all applicable codes and regulations. It is important to verify that all electrical work is inspected and approved by the relevant authorities. Consider the long-term implications of the installation on the environment. Choose environmentally friendly materials and construction practices whenever possible. Explore options for energy efficiency to minimize the environmental impact of the installation. Ensure that the installation is designed to withstand the local weather conditions, including extreme temperatures, wind, and rain. Use materials that are durable and resistant to corrosion. The NEC is updated regularly to reflect changes in technology and safety standards. It is important to stay up to date on the latest NEC requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA.